So yesterday we have seen about deployment object in order to install some few applications like Nginx. That is what we have seen. Before going to the next application that we deploy, I just want to discuss about another topic, which is nothing but a Daemonset. What is that exactly? Where we have to use for what kind of applications we have to use this particular object in order to install your applications. Okay, so let us try to understand that. First of all, what is Daemonset? What makes a difference between the deployment and the Daemonset? So in the deployment, we used to set replica. Okay, so replica is equal to 2, 3, 4, 5, maximum 5, not more than that in the productions or whatever it is. Minimum 3. Okay, so that is what we used to specify deployment for the replicas. But when you specify the replica is equal to 3, when you have couple of compute nodes, let's say more than 5 or 10 compute nodes to your cluster, can you guarantee that this particular application will be distributed equally on all the nodes? No, right? Okay, so 3 replicas in the sense it will run or 3 replicas, maybe all the replicas will run on one compute node, or 2 replicas will run on one compute node and 1 replica might run on another compute node. And let's say all the three replicas are running on 3 different nodes, for example. Okay, but what about other 7 nodes which are left, which are where my application is not running on that particular nodes? Okay, so that is one particular issue which we have with the deployment. And the deployment is only to ensure that your applications are running with the replicas. I don't care where they are running. Okay, because I'm not bothered about on which node it is running, but my replica should be running with 3 or 4, whatever the number I have specified. If that is your concern, then you can go with the deployment. Okay, with the deployment object. Now there could be some situations where your application need to be running on all the nodes to gather some information. Let's say, for best example is to collect the logs. Let's say you are using some monitoring tool or some log collector like EFK, Elastic, fluentd, Kibana. Okay, in that the log collector is nothing but fluentd. So that particular fluentd application should be running on all the nodes. Okay, when you are deploying the monitoring tool, you will understand this. So that application need to gather the logs, information which is present in the logs, and give it to the front end application like elasticsearch. Okay, so to do that, that application need to be running on all the nodes. How many nodes you have? Okay, let's say you don't know about it, your application doesn't know about it, or your kubernetes know it, but your application doesn't know how many nodes you have. But whatever nodes I have, on all the nodes I need to install my application. Then you need to go for Daemonset. So Daemonset will ensure that your application is running on all the nodes. So that's the reason we don't have a concept called replica in Daemonset. Okay, so it looks like this. Let me show you through diagram how it looks. Okay, so if you look at this particular diagram, okay, this is your Daemonset. Okay, this is your cluster, and let's say you are the user who is trying to contact to the API to create a Daemonset. So once you specify the Daemonset, you don't have a replica concept here, because your Daemonset will try to launch a pod, at least one pod on each and every node. You can see here you have 3 nodes here. On all the 3 nodes, it will try to launch at least one pod on all these nodes. Okay, not more than one, only just one pod running on each and every node. Okay, so that is how it will ensure. So you might ask a question like, tomorrow if I add a new node to my cluster, what will happen? So if you add a new node to the cluster, immediately control manager will intimate to your API server. API server will check the information, and that's how it will intimate to your Daemonset, and Daemonset will create another pod on that particular new node as well. Automatically it will create. No need to worry from your end. If this node is removed, automatically that pod will get evacuated from that particular node. Okay, so whenever you add a new node, it will launch a new application on that particular. Okay, but it will ensure that on all the nodes, in your cluster, this application is running. Okay, so that is a benefit we get from the Daemonset. If you have an application like that need to be running on all the nodes, no other choice you have to go with a Daemonset. Okay, and in the Daemonset, not only that, let's say I have 10 worker nodes, for example, By default, the Daemonset capability is to launch on all the 10 nodes at least one application. That is a default behavior. But still we can control that. Let's say out of 10 nodes, I want to launch pod on each and every node except one particular node. Except one particular node, because that node doesn't need any log information. Okay. So in that situations, can my daemon set I can control that? Yes, you can do it with the help of labels. Okay, node labels, that is called as node selector or something like that. Using that particular capability, we can still control the daemon set. Okay, we can control. Okay, it is not the default behavior. We can still add some particular control to your daemon set, saying that on whichever node it should launch the pod. Okay, so based on the labels that we will see when you come across the topic called scheduler, then you will come to know what are different types of labels we can specify to your nodes, pods and all. Okay, there we can discuss it. Now assume that your daemon set has a capability of launching the pod on each and every node. Okay, so we will take a simple example and we will try to see how this particular daemon set will behave. So we don't have scale in and scale out. You don't have a replica, so which is nothing but you don't have a scale in and scale out. You cannot do that. Okay, in the daemon set. But other things you can do. If you want, you can upgrade your application. If you want, you can roll back your application. So roll out and roll back is possible, but scale in and scale out is not possible in the daemon set. Okay, so it will ensure that on all nodes in the cluster, one pod was running of that application. That is the purpose of your daemon set. Okay, so this is present under SEC images. You can check with the daemonset.png. Okay, so here is the diagram related to your daemon set. Okay, now going further, let us take a simple example. This is a fluentd example we will be discussing when we come across a monitoring tool. Okay, so right now we are not bothered about this. So the next simple example is Nginx. Okay, always we take an Nginx example to deploy this. Now here you can see, as we discussed, right, this daemon set will try to launch on all the nodes whose labels is matching with app, front-end, web server actually. So like front-end web server, it is this. Okay, nodes which doesn't have the label defined, they are skipped from launching it. Okay, so now we are not using any labels actually. To be frank, we are not using any labels right now in order to launch this particular application. Okay, so let's try to execute this. Here there is one new parameter which I have written here, which is nothing but toleration. Actually, why I have written this, because I want to launch this particular application on my controller node as well. Daemonset has to go and to launch on the control node as well. So that's the reason I gave this. Why I gave this? Because there will be a taint. Okay, there is a concept called taint and toleration actually. So I want to discuss at that point of time, but here you got a parameter like this. Okay, what does it mean is nothing but I will be so simple to explain. Let's say there is a label assigned to your node that is called as taint. So there is a taint applied to your master node. Okay, so that's the reason by default if you try to launch an application you cannot. But if you want to launch your application on the control node as well, you need to match your taint with the toleration. So your toleration and taint's parameter should be equal. Then only it can launch on the master node as well. So what is that taint which is applied on that node? Let me show you. So kubectl describe node control plane. Oh, sorry, control plane. No, okay, that's okay. If we scroll up a bit, see, here is a taint. So what is your taint? Node-role dot kubernetes dot io master no schedule, right? Here you can see node-role dot kubernetes dot io slash master value is equal to no schedule. So if this toleration is matching with this taint, automatically it is allowed to launch. Okay, this is called as taint and toleration. So there could be some situations where you don't want to launch each and every application on the scheduler should not launch a particular application on the nodes. A specific node is there, it should launch only specific applications. Okay, other applications it should ignore my node. In those cases, you can add a taint like this. There is a taint called no schedule, no execute, something like that. We have a taints as well, multiple taints which we can apply. Every taint has a specific meaning. So no schedule in the sense what your scheduler will skip this particular node from launching the pods. That's the reason by default your worker controller node is not allowed to launch the pods. Okay, if you want to launch the pods on this node as well, we need to match this particular taint with this toleration what we have written here. So taint should be equal to toleration, then only this particular application can be launched on the respective node. Okay, that is the thing which you have to remember. If you don't want this headache, you can directly remove this particular taint. So we are not going to do this right now, but we have a separate session for this. Okay, now remembering that point. Okay, so let's go ahead and let's try to execute this. Okay, you can see the API version is app/v1. Daemonset is the kind what we are trying to create the object. Metadata for this particular object, the name of the object, Daemonset is front end. This is the label where it will try to identify your pods, front end hyphen web server. Okay, copy, then paste. Here you can see there is no replica, sorry, concept. Okay, Daemonset nginx dot gr. Done. Okay, now let's try to create this. kubectl create -f. So now I not specified anything, no replicas, nothing, right? Let's say I have two nodes, so that I need to see only two pods which are created. Let's see whether it is correct or not. kubectl get all -o void. You can see here another container is also under creation process on the control plane. Why it is taking such a time? Because till now we haven't launched any application, right? So there is no nginx image 1.14.2. So that's the reason it is taking some time to launch, to download the image, and then it will create a container. So that's the reason for the first time it is launched on that particular node. So it is taking few minutes to complete the task. Okay, now if I see, I think it should almost complete. Yeah, you can see there two pods are created, exactly two pods. Why? Because I have only two nodes. One pod is running on compute plane, you can see here, and another pod is running on control plane. Did I control it? No. So that is a default behavior of your Daemonset. Okay, so we don't have any concept, as I told, nothing much to discuss actually. If I try to curl, obviously I will get the okay, welcome to nginx page for sure. You can see, right? And here if I give this application as well, it will. That's okay. So this testing we already did some for so many applications. Now we need to understand the concept of this particular Daemonset. Now this particular Daemonset, I don't have any replica. So let me try to apply, though it doesn't have, let me try to apply and see what will happen. Okay. So kubectl scale -hyphen replicas is equal to, let's say, 3 Daemonset slash front end. Okay, you can see could not find the requested resource. Okay, the server could not find the requested resource, which means that your Daemonset cannot be applied with the replicas. Okay, if you look at your scale help, okay, it will tell you for which kind of object it can apply the replicas. You can see here, set a new size of the deployment for a deployment. Okay, it can be used for deployment, replica set, replication controller, and there is another topic called stateful set. We haven't discussed yet. Okay, but it is not allowed for Daemonset. So always I recommend to give help and see, they will, it is in such a way, it is written so beautifully, like even the new persons who are new to this particular Kubernetes can understand by looking at this particular output. Okay, this particular help will explain you so many things. Okay, they have given you some examples as well how you can apply this. Okay, so this is really useful when you are writing some examination. Okay, what should be the current size and what should be the scale, that is also written here, replicas and current replicas. Okay, so this is how it is. So in this way we can control the scales. But anyway, your Daemonset is not allowed to scale in and scale out because your Daemonset doesn't work on replicas. Okay, so that's the thing which I want to show. And the next thing is nothing but upgrade. Upgrade process works as it is how your deployment is working, but here there is a two different strategies here. Okay, in what we have seen in the deployment, what are the strategies we have seen in the upgrade process or a downgrade process? One is rolling update and one is recreate strategy, right? So these are the two strategies which we have seen when we worked with the deployment object. Now in the Daemonset, same whatever you have in the rolling update, same thing will be you got in the Daemonset as well. Both are same. Okay, but here we don't have anything like recreate. We have on delete. Okay, so what is on delete and all, let's try to understand. If you want to understand this strategy concepts of this particular Daemonset and all, just go to the KTS documentation, kubernetes. In examination you will be allowed to access this particular URL. Open to the documents, search here like Daemonset. Okay, simple. Open the first link. Don't open any blogs. Okay, sometimes they are not allowed to open. Okay, so here you can see the example of fluentd, same. Okay, so here I just want to explain about the strategies. Okay, so taints and tolerations if you want to execute your node on that particular control plane as well, or if any node is applied with a taint and you want to launch application on that particular taint node as well, you need to write your toleration. Okay, then where is the strategy? Let me search with that. Okay, strategy. So updating a Daemonset. Okay, so here is a strategy which is written performing rolling update on a Daemonset. Here it is written in a separate document. Let me see. It should be an official document. Okay, let's see. Yeah. So here you can see managing cluster daemons. It is nothing but you can see here Daemonset update strategy. Update strategy in the sense update or downgrade, whatever rollback, update or rollback, whatever it is called as rolling update, and this is called as rollback. So when you are doing a rolling update or rollback, you have to understand that on delete and rolling update. So rolling update is a default, whether it is a deployment object or a Daemonset, both has the same default parameter called rolling update. Okay, then we have something called on delete here. There we have seen in the deployment it is called as recreate, but here it is called as on delete. Okay, so on delete in the sense what is the strategy, how it works and all we will see later, but we rolling update you already know. Okay, now whatever the Daemonset I have created, by default it is a rolling update. You can see here kubectl get Daemonset shortcut name is ds, and then front end. Always you can see the shortcut names with the command which I've told, right? kubectl API resources. So strategy you can see here rolling update. You can see the rolling update strategy how it is getting applied. Okay. Now, so anyway, let me upgrade first with the rolling update, and then I will see with the on delete strategy. Okay. So how to do an upgrade? There are multiple ways, as you know. One is like kubectl set command, or your kubectl edit, or kubectl patch. Okay, so let me try to do a kubectl edit, or let's say set. Okay, so here instead of deployment it is Daemonset. What is the Daemonset name? It is front end. And then what is the image we have used? Image is Nginx. What is the container name? Web server, right? So here the container name is web server. Okay, and here Nginx only. I want to use 1.19.0. Okay, enter. You can see that particular warning, it is getting deprecated as we discussed yesterday. So now it is applied. Let me get the details of it. Here you can see it is getting created. Okay, this is 8 minutes and this is 2 seconds. Okay, so container is creating right now. Can someone tell me, while doing this particular rolling update, what happened in the background? Yesterday, you have observed that it will create a new pod first, and then once a new pod was created, old pod will get deleted. But here, can someone tell me what is happening? So what you have observed? So here the
Once it is
difference.
done one
Sorry?
node,
No. Yesterday,
once it is done one node, then it will move to another.
that's okay. Yesterday, how it applied your upgrade is nothing but it will pick a bunch of pods or a single pod, let's say. First, it will create a new pod. Okay, then only the old pod will get deleted. Okay, but here if you see, first it will delete the old pod, then it will create a new pod. Okay, it's a bit difference between your deployment strategy, update strategy, and here though you are using the same upgrade strategy, okay, rolling update strategy, but here the difference is it will delete the old pod because on a node we need to run only one pod, right? Daemonset strategy is nothing but on every node we need to run only one pod. If it is only one pod, how you can create a new pod and delete the old pod? Then it will be count like two, right? So that is a default behavior, right? So that's a reason Daemonset what it will do. First it will delete, it will pick any one of the node. Okay, it will delete the pod and then it will create a new pod. Whereas in deployment, it will create a new pod. Once a new pod was created successfully, then only it will delete the old pod. Okay, so that is the main difference between your rolling, though you are using a rolling update, here the behavior is different in the deployment and Daemonset. Okay, so this you have to remember. If someone asks in interview like how is that applied, you have to be in a position to answer this. Okay, slight difference is nothing but though you are using rolling update strategy, in the deployment it will create a new one and then it will delete the old one. Okay, but here it will delete the old pod and the new pod will get created with the new changes. Okay, what is a new change? It is nothing but 1.19.0. You can say both the containers have been created. It is 111 seconds ago. Okay, so that's how it is. You can say it is successfully created. So now yeah, so this is done, right? Now I will change the strategy. Okay, so here I have used a rolling update strategy and I upgraded. Okay, now I want to use on delete, and let me try to show you what is that on delete is about. Okay, so on delete in the sense, let me try to first change it and let me show you the behavior and let me explain it parallelly. Okay, so I will be using the same. First, let me edit edit ds/frontend. Okay, let me go to the strategy section. Sorry, rolling update strategy section. Yeah, delete this, and in here instead of rolling update, it is called as on delete. Okay, on delete. O capital letter, D capital letter. For recreate, only just R is capital letter, no C capital letter. Okay, so this is applied. Okay, now if you try to do a describe of your Daemonset, okay, if you try to see, your strategy is nothing but on delete. Okay, so it will not get affected immediately. Only when you try to do some upgrade or downgrade, you will come to know how this particular strategy is getting applied. Okay, so this is your current daemon set which is running with 1.19.0, right? If you look at your rollout history, you will come to know how many times you have modified your daemon set, means upgraded or gone downgraded, whatever it is. Rollout history ds slash front end front end. Okay, you can see first revision is what you have applied with 1.14.2. If you want to see it, you can just give revision is equal to 1. Okay, you can see there it is 1.14.2 what is the image that it has used. Okay, in second revision you already can see the change cause it is 1.19.0 image what we have used. Okay, now Let me try to, I have modified the rolling update strategy. So let me see if I try to upgrade now, what will happen in the background for the Daemonset. So it's a simple command. I will use again set command, set image. Okay. And here I can give something like 1.19.1. Okay. And then apply this. So it is image updated. Okay. If you try to execute this command, it will show you 1.19.1. But here you can see it is old pods. You can see 5 minutes and 4 minutes. If you keep on execute this command, nothing is getting affected. You can see it is 5 minutes, it is not even 1 minute or some seconds, right? Nothing is happening to your pods. Why? On delete strategy, in the sense, okay, only when you delete your pod manually, then only the new pod will get created, right, automatically. So that pod will get created with the new changes. That is called as on delete. You have to delete, then only it will get created with the new changes. That is called as on delete strategy. Automatically it will not happen, you have to do it manually. Okay, see how it gets changed. I will take this one. Okay, I will try to delete kubectl delete pod and the pod. Okay, I deleted this. What happened? Oh, sorry, here it is. So now this pod got deleted. Okay, now okay, if you look at this, you can see the new pod is getting created, right? So let me show you. Once this is done, I'll show you the proof whether this particular pod is created with the new changes or not, and the old pod is still available. It should show the old version of Nginx, right? So let me show you this. Kubectl capital I. If I execute this, you can see here it is using 1.19.0. But what is your current requirement for your Daemonset? It is 1.19.1. Okay, so let's see the new container, new pod. So if I execute curl, okay, this is the new pod, right? So if I give capital I 37 seconds ago, which is nothing but new. Now here you can see that 1.19.1. So with this proof, I can justify that this pod which was created with the new changes, right? Whatever I specified in the Daemonset, with that changes only, it is right. Or else you can look at this particular statement, output of this particular Daemonset. It is clearly showing you that out of two pods, okay, one pod is up to date, second pod is not up to date, one of the pod is only up to date with the changes. Okay, your expectation is 1.19.1 with the image, and one of the pod is only running with that particular changes. The rest of the pods are not running. Okay, even if you want, you can just give a describe for more information. Okay, describe Daemonset slash front end. You can see, okay, two are running successful. Up to date pods, you can see here one. Number of nodes scheduled with up to date pods 1. Okay, number of pods scheduled with available pods 2. That is, nothing is misscheduled, so that's okay, fine for us. Okay, but as per this particular strategy, now this particular Daemonset is only having one pod up to date with the new changes of your Daemonset. Other pod is not done. You can see here I've deleted this particular pod, and the new pod got created, and it was created here as well. Okay, so now if I want to apply for all the pods, okay, now the second pod, right, this one. Okay, so what I want to do, yeah, this one only, yeah, this one. So kubectl delete, this pod is also getting deleted. So the new pod, when got created, it will apply with the new changes. It doesn't take much time as per my expectation, yeah, because my compute node already has that image. Okay, only control plane, it will take some time, that's it. Okay, so this is how it is. Now let me try to modify the Daemonset once again with the, I will just want to upgrade once again. Okay, at a time, if you want to do on both the nodes, both the Daemonsets, how many pods you have, if you want to apply for all the pods, let's see how we can do it. Though you have some downtime, it can be done for all the nodes. Okay, all the pods actually, sorry, my bad. Okay, so now you can see your expectation is to run with the Nginx latest image. Okay, but your existing pods are running with 1.19.1. Okay, so now if you want to apply for all the pods at a time, there is a simple thing which is called as scale out. We don't have it, right? So that's a reason we cannot do it actually. So the only thing is like you have to delete two pods at a time. Okay, both the pods at a time, and then you can upgrade it. See how I will do it. Delete pod. Okay, you can give this one, and both the pods got deleted at a time. See, like how many pods you want to give, you can give with the space. Both the pods got deleted at a time, and both the pods are getting created at a time. Okay, that's how it is. Though it is not a feasible solution, but yes, if you want to do it. Okay, let it get completed. I hope so. It is done. It's almost. Control plane, it will take some time. Why? Because it should download the image, right? In compute plane, I already have these images. So I guess this is done. Yeah. So now you can see your application is like up and running. So which is like fine with the new changes. So if you want to see whether it is having the new changes and all, so you can take this, okay, and you can see this Nginx is running with the latest version. So let's wait, or else I can run here as well. It's taking some feedback.
Sudhir, uh, the real-time basically use of Daemonset is where we can use in terms of
So
real-time.
that is what we are saying, right? So Daemonset is something where if you need your application to be running on all the nodes, for example, your log monitoring tools or any other tools which need to be running on all the nodes, right? So they have to fetch the
Okay,
log related information of your applications, or if your nodes, everything should be running on all the nodes. So in those cases, you
okay,
have to run your application irrespective how many nodes you have. On all the nodes, I need to run my application. So then this is the choice
okay,
which you have to pick to do that particular task. Okay.
okay,
Yeah.
okay. Thank you.
So it's not responding. Just a second. Let me see. Or else we can keep it aside. So we can see the image version. The latest in the sense it is using 1.21.3. So that is the latest version of your image Nginx right now. Okay. So this is all about your daemon set. So daemon set in the sense it will try to ensure that how many number of nodes you have. On all the nodes it will run your application. Only one pod will be running on each and every node. Okay, you cannot run two pods. Okay, so you cannot run two pods on a specific node. Only one pod will be running on each and every node. Tomorrow if you add a new node also, it will try to launch your pod on that particular node as well. Okay, once it is successfully joined, a new pod will be launched on that particular node automatically. Okay, so this is all about daemon set. Now with the help of this particular, now you know the concept called daemon set, deployment, stateful, sorry, first of all we know about how to deploy your application using standalone pod. Then we have seen replica set, replication controller. Then we have seen deployment. Then we have seen daemon set. Okay, so now let us take some real-time examples of Jenkins or something like that and see how we can deploy our applications. Actually, to do or to access that, we need a service. Okay, service in the sense you need a service kind of concept where you can expose your application outside using some node port or something like that, and you can access your application. Okay, but since we haven't discussed about service right now, it is a bit, you can just remember actually for time being. Later we can discuss about service in depth, but let me show one example. Okay, I don't want to confuse too much on this actually. So let us take a deployment. We have a Jenkins, right? So this Jenkins, we are using a service actually. So this service is nothing but it will use a node port. You can see here. So node port in the sense on each and every node, it will open this particular port number. Okay, 8080, and that port number will be binded to the backend ports you are using. It's like a load balancer, and this service is like a load balancer. Okay, load balancer in the sense how many pods it is running. Your request will be sent to your backend pods in a round robin fashion. Let's say you have totally 5 replicas, okay, of your Daemonset. For example, let's say, sorry, deployment. Your deployment is having 3 replicas, okay, which is nothing but 3 pods, right? So now this particular service will be acting as a front end. Okay, all these 3 pods are running behind this particular service. Okay, so this particular service, how it looks, let me show you, so that will answer. Okay, now if you look at this, okay, look at this example node port. Okay, so this is your service. Okay, this service is exposed as a node port. Okay, how many nodes you have? On all the nodes, this particular port number will be opened, what you have written, and that port number, if you try to access your node with this IP address, it will reach to the service, and from the service it will go to the backend pod. Which pod? It will do a round robin fashion. Request, first request will go to the first pod, second request will go to this pod, third request will go to this particular pod. So this is how the service will work for you. It is like an internal load balancer for your Kubernetes. Okay, so that's how it is. So I'm trying to use this particular concept for now. When we come across the topic called services, maybe tomorrow, then we can discuss more about what is service and all. But right now, remember that a service is like a load balancer, internal load balancer for your Kubernetes, okay, for your backend pods. So now let us take an example of your Jenkins and let's try to deploy and see what are the challenges we face. I think this one is not needed actually. I have written. See, by default, if I don't specify anything, it will use a cluster IP. That is a default behavior of service. But now I need to use a node port. So that's the reason I want to use this one, this particular service. I will remove in the file, but right now let me try to create this. Copy. Let me take this example. I need to go to the deployment directory and then Jenkins.yaml. I will remove this particular section. In a single YAML file, I am trying to create service as well as deployment as well, right? So let me do it. So I'm trying to do both of them at a time. Here is it. So for your Jenkins to be accessible from outside, the important host path, sorry, what is this host path? Let me remove this one. This is not the one. Okay. Here, this one should be parallel to your this. Path and then type. Okay, so this is fine and this is also fine. Replicas, let me try to give 2 and let me try to see what are the challenges we can see. Okay, what are the challenges we will try to observe. Okay, deployment, everything you already know. Okay, here the important port numbers for Jenkins is nothing but 8080 port number and 50,000. 50,000 actually it's for internal Jenkins slave communication actually, but actual dashboard you will be accessing on 8080 port number. So that's the reason in the service we are trying to send a request for your service to the backend ports on 8080 port number, not on 50,000 port number. Okay, right now. So let's take this one and yeah, I'm okay with this. So let's save, and here we are using a volume type called Jenkins underscore host path, which is nothing but this particular directory will be created on the nodes where your Jenkins is trying to get launched. Okay, so kubectl create -f deployment. Say for Jenkins, Daemonset is not a right option. So that's the reason we are not showing the Jenkins example for Daemonset. It is only for deployment. Even MySQL example, which I'm going to discuss today or maybe tomorrow, I'll be talking about only deployment. Daemonset example is perfect suitable for the applications which you want to run on each and every node, like fluentd. We have told, right? I have told that EFK will be deployed in our Kubernetes cluster to fetch the logs. So in those case, EFK in the sense elasticsearch, fluentd, Kibana. That fluentd component should be installed on each and every node. So in those case, we will use Daemonset. Kibana will be running as a deployment. and your elasticsearch will be running as a stateful set actually. So it is covering all the three topics, this EFK. So that example I will show you only once we have discussed about PV PVC concept, stateful set, everything, then only we can discuss about EFK log monitoring tool. Okay, so right now we will go with these examples. Tomorrow I will show you one more application, how we can use it and all. Okay, so different applications, Node.js applications, Jenkins, MySQL, Nginx. Okay, which you will come across daily in your organization. So yeah, so deployment is done and the service also created. So kubectl get all, it will show me all the details, service, pods and everything. You can see here Jenkins is under creation process. You can see Jenkins service was created with the node port, and this is the cluster IP, and this is for cluster IP, this is the port number, and for the node port, this is the port number which is open, 31,990. Okay, which means that if you go to the browser, you need to use 31990. Okay, any node IP. It's not only that it is a control plane or compute plane. It doesn't mean that where the pod is running on that particular node. No, it will open this particular port number on each and every node. Node port behavior is like that. Okay, you can say both the pods are launched on compute node. I already told you, right, the default behavior is it will not launch your Jenkins on any application on control plane node by default. If you want that, what you did in your Daemonset YAML file, right, adding a toleration, you also need to add in the toleration for this particular deployment object as well. Okay, that's okay, we are not bothered about it right now. Let's say image crash to backup error. Okay, let's see what happened to this. Maybe some permissions issue or something like that. Let's try to understand. So kubectl logs. You can see there is a permissions issue, as I know. Okay, so what does it mean is nothing but, so it is trying to create a directory called /mnt. Under that is trying to create a Jenkins. If you try to look at the ownership of this particular Jenkins directory which is created is nothing but root. So that's the reason it is not having the capability of doing it. So what I need to do, I need to change it to nobody, no group, so that it has the capability of writing the data. Okay, yeah. So now I have modified the ownership. So if you see, it is nobody, no group, right? Let's see what will happen. Crash loop back off in the sense it will try. Last restart was happened 17 seconds ago, and this was happened 18 seconds ago. Let's wait. So these things you will come to know by looking at the logs. So that's the reason I executed this logs. I came to know there's a permission issue. Why it is showing you like var Jenkins underscore home, because if it is writing the data over there, it is nothing but it is trying to save in the node as well, right? So node doesn't have a permission for you to save the files. That's a problem. So let's wait. If it is still not fixed, then we have a different scenario to follow. Error, still it is showing you error, right? Fourth time also. Then what I can do instead of doing like this, your Jenkins user will be 1000 actually. Okay, so we have to give that. Now if you look at your ownership of this particular directory will be your user, test user, test user. Okay, now this will solve the problem. If that doesn't work, you can go for it. So Jenkins user in the container will be used as 1000. So that same permission I have given it to my what do we say, my directory in the node. So user Jenkins will not be available on my node. So that's the reason I gave ownership with the numbers 1000. That will get accepted. Okay. It will take in the next restart. It will get fixed. So let's wait for the next restart. I don't want to delete this pods actually. I just want to show you that in the restarts, it will try to identify that particular issue. If it is solved, it will continue with properly, or else again it will show you crash loopback of error. I just want to wait. Here you can see now it is running, which means that in the fifth restart, it identified that issue. So issue is solved. Now your pod is running. Second pod is also under creation process. Maybe let's wait. You can see it's successful, right? So now the issue has been resolved. So you can just copy this particular issue. I'll just save it. I will update in the notepad. Okay. So this is, I will try to save. You can just add solutions to this. Yeah. Okay. Coming to the point, here my application is running. Okay. Now I will go to the browser and I will try to access. Let's see how it goes. 192.168.1.50, sorry, 90 colon, what is the port number? It was opened with let me see, 31990, right? 31990, right? Enter. So now it should access my Jenkins. Here is my first question, or you might have, I thought like you people will be asking me, which, okay, I'm hitting this particular URL. It will go to the service. From the service, it will go to any one of the pod. So first, what parameter do you get? Oh, just a second, something went wrong. Put 0. Just a second. Just taking few minutes to 31990. Yeah. Okay. So my question is, so when you're trying to hit like this, which pod IP address you will try to pick in order to give it in the initial admin password? First, you will get an initial admin password, right? So what you will give? Which pod? See, both the pods are different right now. Data is not getting replicated. Or let's say, okay, both are using the same host path, right? Okay, you might have given some justification saying that, okay, both the containers are launched on the same node. That's the reason this directory will be shared by both the containers. Yeah, that is true. Both the pods will share the same directory. Okay, fine. So then now which IP address or which password I need to take? Okay, you might say that I need to go to instead of going to the pod, I need to go to secrets. Okay, and then I need to go for initial admin password and try to take the password of this particular file. Okay, I'll be taking this. That's fine. Okay, I'll take this particular password. I will give it here. Okay, we are continuing right now. Never. If both the pods are launched in two different nodes, then which I would say, you can see here Jenkins instance appears to be offline. Okay, skip plugin installation or something like that, or let's say skip continue. Let's say you want to create a user. So let's say again, if I try to do a refresh, see what happens. Again, I'm getting initial admin password again. Okay, let me try to give the same password which I gave earlier. Continue. I need to get that what do you call this plugin installation page. Okay. Okay, if both the pods are launched on two different nodes, which password you will take? No, right? Which pod password you will take? None of the pod, because you are trying to do a load balancing. If you try to do with one particular password, let's say by trying to fetch the data, you got one of the pod password, you gave it, you continued, but tomorrow when you refresh this particular browser, the request might go to the second pod, then again it will give you the initial admin password. So in this scenario, for this kind of applications, it is not recommended to use more than one replica. Okay, it is not recommended to use more than one replica. You have to use only one replica. And but so don't assume that it should be deployed as a daemons. What do we call this particular pod, standalone pod? No. Why I'm using deployment object in order to install Jenkins? Because tomorrow, if unfortunately this particular Jenkins pod is down, automatically my control manager will try to create a new one. Okay, so that is a capability where my deployment will provide me. And not only that, tomorrow if I want to upgrade my Jenkins, I can upgrade that as well. Okay, so for this particular scenario, this particular task is not possible. You can see here I'm getting this unwanted pages and all. Okay, you can see how it is displaying it, unnecessary data and all. See, continue again. If I give continue, it is asking two things at a time. Okay, so this is the unwanted behavior which you try to see. You see, it depends upon application. First of all, we have to understand the application behavior, then only we have to decide what is the approach we have to follow if you want to deploy an application like this. Example, that's the reason I took this example of Jenkins, to show you that we cannot use more than one replica for this kind of scenarios. Okay, so that is how it is. So in this scenario, this is not the case. So always you have to use only one replica at a time. Okay, so now what I can do right now, I will reduce it to one replica. So how to do that? kubectl scale hyphen hyphen replicas is equal to 1. Okay, then deploy slash, what is the deployment name? Jenkins hyphen deployment. Done. Replicas. Oh, you understood, right? So it depends upon application as well. We cannot say that every application can be run with 3 replicas, 4 replicas, 5 replicas. No, that is not the case. Okay, so that's the reason I'm not discussed about that particular point till now. Why? Because you have to understand it practically. Okay, now this particular application is running with only one pod. Okay, let me go with it. Let me try to refresh it now. I have to get a response from only one pod. My service is load balancer is having only one pod behind that particular load balancer. Okay, so let me do it. Let me get a response from there. It is still available, right? So let me take this. It will take few minutes, okay, to get a response. Let's wait. It's running. 9 minutes ago it got restarted, so no problem at all. Okay, so let it get refreshed, or I will open it to. Okay, I'm getting a login page. So let me give the password. Now you can get it from the pod as well. Okay, see, my network is a bit slow actually, so that's the reason it is taking few minutes to get a response. Okay, so this password what you see here and the password which I get from logs is the same, right? Just a second. Oh, it is not responding. My control plane is not responding. Is it hand or what? Let's see about this. Or do we have any free memory? Yeah, 3 GB here, and here it got disconnected. Oh, it is up and running. No problem at all. Let me see from here. My control plane. It's okay. Yeah, there is some network issue. Okay, keep that aside. 2 GB was there. That's fine for me now. I click over it. Okay, so this is fine. If you try to check the logs of this, you will get the same output. Okay, click here logs, this particular port, enter. You can see actually these are the issues which you got when you have done like that. Okay, let me try to go back. Oh, we'll try. Let me try to get a response of this. Let me try to see the logs -f in the sense. It will show you the real-time issues. There is some issue with the Jenkins server. Yeah, we'll wait. Or else we will try to redeploy this particular application with from scratch with single replica. Okay. Yeah, let me try to do it actually. It's okay. So what I want to do is kubectl delete -f deployment Jenkins. Okay, you have to remember one more point. You have to remove these particular files as well. Okay, so which files it is /mnt Jenkins underscore home, right? We have so many files here. I just want to remove. I have not removed the directory. I just removed all the files and directory which I have under this. Okay, so that is what I have done here. You can see here. Okay, so yeah. Now I will try to create this with one replica. Sorry. So where is it? Yeah, one replica done. Save it. Now kubectl create -f deployment and then Jenkins. Okay. Meanwhile, you guys can search, like you can do some R&D and try to let me know, is there any other alternative that we can run more than one replica of Jenkins? Okay, any solution? You know about volumes right now? Can we use any other volumes to sort out this particular problem and all? You can just search for that. Okay, I think now the SVC will change, means like the port number will change. Here it is 30736. 30736. See, now we are getting much faster response. So let me check the logs to get the pod initial admin password. So kubectl logs. Okay, now you got this particular password. Give it here. You know about this installation, right? Everybody knows about this. Same steps I will follow in the wizard. This is called as setup wizard. We just installed Jenkins, but we haven't configured. So now we are trying to configure the Jenkins. Okay, this is what we are trying to do. It will take some time because it is running inside the pod, right? So it will take some time to get a response. Okay, lot of factors: network speed, the number of processes running on the node, everything. I have so many limitations. If you want to see the live logs, you can give -f. Okay, so it will try to show the logs. Okay, there are no errors right now for us. Means that is not an issue. It is getting loaded actually. Okay, so this one which you are saying is like it is getting refreshed. The browser will reload automatically when Jenkins is ready. Okay, that is what it is trying to say. Okay, now I got a response. You can see here, this is what the statement you need to get. Okay, then it means that you will get a login page. Okay, so take this particular password, then give it here, continue. then you'll get a installed plugins like suggested plugins, whatever it is. I'll go for suggested plugins. Performed an action check update server successfully at the attempt. Okay, finished download metadata. It took 1,15,877 milliseconds. Oh, I'm getting this Spring security checks and something. These files are created, I guess. Yeah, we have this file, Jenkins files and all. See, that is my network issue. Okay, it's not related to a Jenkins or something. So now we got this particular install suggested plugins. So let's click on this. Okay, it took some time. Okay, it's not Jenkins issue, it's my network issue actually. There are some up and downs. So you can see now it's going on. So it will download the plugins, it will install. So that's how it will go in the background. So meanwhile, I will just pause it. Okay, there is some issue, I'll just resolve and I'll just pause. So a few plugins got failed. So let me try to resolve in the next retry and sort out of installing this particular plugins. Few plugins got successful. You can say sys server folders, trailer API, build timeout, token macro. So these are fine. Few have got failed. So I'll be doing in next retry. Okay, so let's wait. So I'll be pausing the video once again so that it will be going in the background. So as I told, like we need to just do a retry. So in the retry, whatever the plugins got failed to install, so that will get installed. Okay. So retry. So it will try to install these many uninstalled plugins. Okay, which got failed in the earlier attempt. Okay. So let me pause once again. So why? Because it will take few minutes to complete this particular task. Okay, you can see already it is done with 4 5. Okay. So this is how we get a login prompt. Let's try to create a first admin user. So this is the login page which you see. Like you can see my user details and all. So all the plugins have been installed and this is how you get a login prompt. Okay. So thank you. So in the next demo we will look into another topic.